Hello everybody and welcome back to SkySaga Alpha 9. We're over here on the tutorial island and it is time for another tutorial Tuesday. So today we're going to be looking at randomization and how you get a random Lumostone signal in SkySaga. So basically this is actually quite a difficult challenge because randomization can be done in a couple of ways and we don't really have access to a lot of those. So basically, the easiest way, and the way that randomization is done normally in the real world and not in Lumostone, is some very long, very complex maths equations that you can't do with AND gates. They actually have to be done with very interesting and intricate maths combinations. And also, these things are usually done based on a seed, which is usually taken from something that happens very, very quickly, or is a little bit random in and of itself. So usually this is something like the milliseconds in the system clock for your computer, or it will just take a very, very quick sampling of the microphone. It will take a couple of bits out of the microphone sample, and it's just going to kind of quickly use that, and those are going to be relatively random because, I mean, microphone static and background noise and things are in themselves very, very random. But we actually can't do any of that stuff here because we don't have a randomized entity that we can then get access to. So I have added a whole bunch of extra stuff back out the end here, and what we're going to be looking at today is what's called pseudo-random. Now, pseudo-random is a little bit different to the other types of random. Now, basically the way this works is that you get something to change so quickly when somebody's pressing down and holding onto a button that you can't release the button fast enough to have things land where you want them to land. So it's basically randomness by going really, really fast, essentially, is the way this thing works. So, and this is exactly what I've got set up here. So if we stand on this pressure plate, it will randomize the top line up here. And if I stand on here, you'll see that this does actually cycle pretty quickly. It cycles a lot faster than this in the actual back end, but the lights take a little bit of time to actually update, so it ends up not looking quite as fast. But I can step off here and you can see that it does keep changing after I've stepped off, just because this thing is cycling so fast that the actual lights need a little bit of time to catch up to where things end up. So as you can see, we get different random codes out of this every time I step on and step off. It does seem to have certain preferences, and I'm not exactly sure why some of these random keys are weighted heavier than others, but as you can see, by standing on this pressure plate for different lengths of time, it cycles round through different combinations and then goes through and actually picks one when I stand off again. So at the moment we've got 2 and 2, and then this front circuit is still hooked up as it was last week to the comparator setup that we have. So once I actually set up the same code above and the same code below, I can get access through the door. So this thing, as you can see at the back here, this one is a little bit messy, but we'll go through and do up our own in just half a second here. So the key to this all is actually this little clock over here. So this is a 2 NOT gate clock, and it is literally just sitting there spiraling back and forth and ticking at the fastest that Lumostone can tick. So this is the input to our system that allows us to cycle through so fast that you actually can't stand off the pressure plate and get the very next result, or stand off the pressure plate and get the result that you're currently seeing. So let's head over here and we will have a quick look at how to build this thing. So to build this one, we're actually going to build it in 3 parts. Now the 3 parts are a counter, a input with clock, and then also a 0 insurance. So we'll talk about this in just a little bit when we get there. So the counter itself is actually pretty similar to the counters we've got all over this island right now. There is a very big one here, there's another one, little one over there, there's one obviously at the back of here now because I updated that between episodes or between tutorials, and there's also another one over there. So there is a video on my channel already about how to build this counter, so I'm going to kind of run through this pretty quickly, and I'm just going to build a 2-bit counter. So for each bit you need 1 Lumostone latch, 2 AND gates, 1 NOT gate, and then you also need 2 NOT gates for the joins between each section. So the join between the first section and the second section, I need 2 NOT gates. If I had a third section, I would need 2 more NOT gates for the join between the second and the third, and so on and so on and so on as we go down through everything else. Now, the actual input and the super fast clock is going to be built of 2 NOT gates, 1 AND gate, and a pressure pad, which is pretty easy and simple to do. And then the zero insurance that, once again, we'll talk about later. You're actually going to need NOT gates for each of your latch points, or each of your counting points. So for me, I've got 2 of those, and then you also need a NOT gate for the input, and then you need 1 less AND gate than you have NOT gates. So in my case, I need 3 NOT gates and 2 AND gates, but if you built this with 3 nodes or 3 sections in the counter, then you would need 4 NOT gates and 3 AND gates. So it just kind of steps up a little bit as you go bigger and bigger. So the first thing we're going to do, of course, is to build a counter. So you guys have probably seen this before. If you haven't, I would suggest checking out the video that I've already done on building counters. Obviously, we do need an output as well, but I haven't actually built any of those here, so we're just going to leave those out. But we're going to put down our counters. So our counters are pretty simple. They're a latch, each with 2 AND gates, and I'm just going to place these down just like this, and then each of those has a NOT gate as well, feeding into one of the AND gates. So here we go. Now when we actually link all of this stuff together, the output of the latch gets fed back into the NOT gate, and the NOT gate gets fed into the A side of the AND gate in front of it, and then all of that stuff together gets put into the ON for the latch, just like that. Because this way, when a signal comes through and goes to the B side of this whole system is going to turn this input, this latch, on if it has been off already, and then we take this output of this latch and just put it into the A side over here, and we take the output of this AND gate and put it into the off, just like that. So that's the first little latch counter done. We're going to hook our timing circuit into this in just a second, and then this is our second one. So the join between the two is going to be a falling edge counter. So we're actually going to sit down 2 NOT gates between this, and we're going to run the output of the first latch into both NOT gates, and then we're going to run the back NOT gate into the front NOT gate, just like that. So this is our little falling edge pulse here, and that's going to activate this next latch. Now the next latch is also going to be hooked up the same way, so the output of the latch goes into the NOT gate goes into the A side of the AND gate in front of it, the AND gate goes into the ON over here. This latch once again goes out to the other AND gate over here and the A side, and that AND gate goes into the off, just like that. So now that all of that's set up, we can put our pulse through into this thing. So we take our pulse and place it into the B side of both of these. So if you're going to extend your system out and you want more than just 2 lights, you can of course build another counting circuit, another flip-flop, which is what these things are. You can build another flip-flop over and join it with another falling edge pulse, just like this, and just keep going and going and going and going, as many of these as you like. I would recommend limiting it to kind of 3 or 4 though, because once you get further past 3 or 4, the whole system starts to slow down, just because it takes a little bit of time for the signal to actually travel all the way up the actual system that you've got, and that can mean that some of the upper levels are actually going to be relatively easy to bodge and actually make sit where you want it to sit. So now that we've actually got our counter going, as you can see, we've got our 2 little latches in here. The coolest thing about this, and the coolest thing about using this as a random, we don't actually have to put protection on this falling edge, because it means that this guy is always on, and any latch from this point onwards is going to be turned on because of this falling edge pulse. So you don't actually need to put in anything else. That will just keep this guy on, which is nice because it means when the island starts up, you have a code in your code already, and you don't have zeros, and the door doesn't open just automatically. So here you go. So that's the little counter setup. As I said before, you can just extend this as much as you like, just using the same stuff. So now we're going to put the clock down. So the clock is pretty simple. All we need is 2 NOT gates. So we're just going to stack 2 NOT gates, And as you probably worked out, these just kind of get fed into each other. So one into one and the other back into the other. So here we go, get this nice little cross pattern, and you can see this starts flashing really quickly. But of course we can't just feed that directly into here, we actually need to control it. So the way we're controlling that is we're putting an AND gate between this and the circuit, not having the AND gate in here, because we put the AND gate inside the clock, then the whole clock is going to slow down just a little bit, and we're trying to aim for this thing to be as fast as we possibly can get it. So this is the way we do this. Now we're going to take the clock and put that into the A side of the AND gate. We're going to run the AND gate into the other two AND gates in the first flip-flop circuit, and this is going to go to B on both sides, just like this. Now finally we're going to run a pressure plate. Now if you're puzzle making and using this to randomize a puzzle output, I would suggest making this particular pressure plate also activate something else earlier on in your circuit. So basically, a user comes through and they randomize the code to get through this door without even really knowing about it, because they're stepping on this plate to open something else way back in the maze, and at the same time as doing that, they're accidentally randomizing the code that they're going to have to use later on. And that's just going to add a little bit of intrigue, because if somebody runs your race or your maze a second time, the second time they run it they're going to have a different code, because they're not going to realize that it's a randomized code, and that's going to trip them up, and they're going to actually have to think about it on the second run through. So yeah, there you go, that's our little system setup. Now the only thing that is a little bit wrong with this right now, so this is going to work, and as you can see out over there, this signal is rapidly jumping back and forth through this guy. If we stand off, we'll see that we've got that guy on and this guy off, so that's actually the same signal we just had, but we should be able to change that. I am not being very lucky right now, but it should change as we go through and do things. Now, the final thing that we actually need to do is what I've called zero protection. So one of the random numbers that can be thrown out of this is 0, which is this guy turned off and that guy turned off. And the problem with that is, if you're using a system like I am over here, the default for latches is off. So if your randomized signal is also 0, this door is just going to pop open, and the user or the person running your code or your maze doesn't actually have to do anything. They're just going to be able to get through that door without any puzzle solving. So we really don't want that. So the way we're actually going to tackle this is we're going to use some zero protection. Now the way I've done my zero protection on this guy is I basically just run one NOT gate for the input and one NOT gate for each of the latches, and then we're going to get 2 AND gates to hook all of this stuff up. So what we're going to do right now, we're actually going to take that and move that up further, just like that. So we're going to run the input, which is the pressure plate, into one of the NOT gates, and we're going to run the 2 latches into the other 2 NOT gates. Now what this means is that when both of these latches are off, and also the user is not stepping on the pressure plate, which means that this has come to a stop and it has chosen 0 as the final output, then all of these guys are going to be on all at the same time. So then of course we want to know when that's happened by connecting all of these together. So running the first 2 NOT gates into the first AND gate, one at A and one at B. Then we're going to run this AND gate up into the second AND gate at A, and we're going to run the third NOT gate into the B down the bottom down here. So once again, if you're running a longer, more complicated system than I am, all you're going to need to do is add more NOT gates down and add the latches into those NOT gates, and then just add more AND gates upwards and make sure that all of the NOT gates get ANDed together for a single output, just like this guy. Now, once you've got your single output here for the zero protection, all you need to do is run that into the on side of pretty much any latch you like down your chain. So we're going to run ours into this on side of this latch here. You can of course run that through either a rising edge or a falling edge. Personally, I prefer the rising edge. It's not strictly necessary, but it is kind of nice. So I've left it out here because you can get away with without using it in the circuit or in the web, but like I said, it is nice because rising and falling edges just give a little bit of protection to your circuits, especially the rising edges, because they don't have any default conditions, which is kind of nice. So yeah, there you go. This is how all of this stuff works. All I would need to do now is hook my latches up to 2 lights, and I would have a randomized output of those 2 lights. And then of course you can use all of this information along with last week's tutorial to hook these up to comparators and make a little maze game like I've made over here and what you saw at the start of the video, because we run this thing and then we actually need to work out which of the pressure plates need to turn on before then the door goes on and goes open and we can move on through to the rest of the maze. So there you go, that is it. That is a pseudo-random generator for SkySaga and Lumostone. I hope you guys have enjoyed that one, and I will see you in the next video.